Okay, so today what I want to do is cover some things that we call function arithmetic. So, from elementary school, we had addition, subtraction, multiplication, and division, right? Well, the same things can be done with functions. So here I have f and g of x. Now, towards the end, I'm going to introduce another type of arithmetic. It's what we call inverses. Inverses, they're a bit different, but you should be fine with them. So let's just start. First, we have addition. Now, when you think of addition, is pretty simple, right? We have f of x plus g of x, right? And so what we do, we simply just add these things together. So we just have. Now, I will not be combining them together with common denominators. You can do that yourself because you should be pretty used to how to do it with common denominators, right? You just multiply everything by x squared, right? So I'm just going to do this. Minus x plus 1 plus 3 over x squared. All right, that's number one. Number two, we have subtraction. So let's say we have f of x minus g of x. Once again, I won't be doing the common denominators, but you should be able to do it. So what we have is 3x squared minus 2x plus 1 minus 3x squared. All right, let's highlight these for you so you know what I'm talking, so you know which one is which, right? So third, we're going to do multiplication. Multiplication, I, once again, don't believe you'll have any problems with, so I'll just do it normally. So we multiply 3 towards everything up there, so we get 9x squared minus 6x plus 3, all divided by x squared. All right, pretty straightforward. I'm going to just box these up for you so that it's a little bit more organized. Technically it's more organized, but it's pretty messy anyways. Number 4, we're going to do division. Division, it's basically the same thing. It's nothing really fascinating. Oops. Okay. F of x divided by g of x. So what we do is we have 3x squared minus 2x plus 1 divided by, I'm going to put this in brackets so it's clear, x squared, that's a bit small, and 3. What we do here is we just flip this upside down. I'll show you what I mean here. So because we technically divided by a fraction. 3x squared minus 2x plus 1. Now what we do is we multiply by this. These two are the same thing. And because this is multiplication, it's basically just part 3. It's just number 3. So let's just multiply 3x to the 4th minus 2x cubed plus x squared all over 3. All right, so that's our solution right there. Now the last part I'm going to introduce is something called inverses. If I can delete this, it's quite difficult. All right, so we're going to talk about inverses. Inverses, you should remember from last year in grade 11 math. If you give a function, for instance, if you give a function an input, it'll give you an output. Inverses, on the other hand, if you give it the output of the original function, it'll give you the input of it. So So that's pretty clear. We should also recall this one identity or property is that if this is f to the power of -1, that just means inverse. It doesn't mean 1 over f of x. If we take the inverse of, if we do this, we will always get x, right? This is important because some teachers, they might require you to check your work. So if you need to check your work, you just plug in f of x you plug in f of x into your inverse, and if it all cancels to x, they're inverses. So if the teacher wants you to find the inverse of f of x, you want to follow these steps right here. So we're going to be using this fact up here to help us solve for the inverse. So by the definition of function composition, we could actually just we could actually do something like this. We could do f of, now this is also true if you put just f of x and then you put inside of it the inverse of f of x. So let's put in f inverse of x right here. Now this always equals to x. Now recall from function composition that we can just plug in our f of x. We can treat this as our variable inside of our function. So this is equal to, we don't need that, 3 f of the inverse of x, this squared, minus 2 inverse of x, f of x, plus 1 equals x. Right? From here, we are able to, what we want to do is solve for f of x in order to find it. So what we should do here is subtract. So x minus 1 equals 3. Now this is what we want to solve for. So f of -1 x squared minus 2 f of -1 x. From this part, you might be thinking, this doesn't look good, right? Well, what we can do is actually complete the square, right? And then we can just take the square root and we can just subtract stuff. So we have x minus 1. Now we want to complete the square right here. So let's factor out a 3. So 3. Actually, yeah, 3. F inverse of x squared minus 2 over 3 inverse of -1 of x. Now we want to add something to this so that we can make this a perfect square. What we do is, recall, it's b over 2a squared. We add that, b over 2. Our b is 2 over 3. Well, -2 over 3, but we have to square it at the end. So we just add in 4 over 9 in here. And then this is all bracketed off. Now because we added this in here, we also have to subtract it. But since this is also a multiple of 3, right, we have to divide it by 3. Because technically, we should be doing it like this, right? This is how it should look. So we want to take the negative. We want to take this part out, the highlighted part out, and move it to this side right here. So we have x minus 1 plus 4 divided by 9 times 3, this part times 3, equals 3, well, we can put 3 here, f of -1 x minus 2 over 3 squared, right? These cancel out, so we have 3 down here. So x minus 1 plus 4 over 3. This is equal to x plus 1/3 equals 3, and then we have this stuff in there. All right. Then in the end, we can solve for f of negative x. So we divide both sides by 3, x over 3 plus 1 over 9 equals this thing, minus 2/3, all that squared. Take the square root of it. Then we're left with x over 3 plus 1 over 9 equals f of the inverse of x plus 2 over 3. And finally, we subtract 2 over 3 on both sides. So minus 2 over 3 equals the inverse of f of x. Now, this is a pretty lengthy process, but what can you do really? So this is what we have with our quadratic. We have this square root function. Now let's try doing it with our reciprocal function right here, 3 over x squared. Now this one is a little bit tricky because it's not entirely intuitive what you should do, because there's some tricks in there that you have to be wary of. Okay, so sorry for the cut. I just realized that I made my life really difficult with the example I gave for g of x and when we're doing inverses. So I just created a different example for g of x. Don't worry, everything else still holds true, but we're just going to do this part of the inverse function with this g of x, because this one is going to be a lot easier, and it's not what you're expected to do, unlike the other one, which is much more difficult. So same thing, we have g of inverse of g of x equals x, right? Now let's plug in g of x for everywhere we see x. G of inverse of x minus 1, g of negative 1 of x equals to x. Clearly, we're going to have to cross multiply, right? 3g negative 1 of x minus 3 equals g inverse of x times x. Well, in the end, we're going to want the inverse of g of x, right? So what we can do is move all of our g of x to one side and then factor out the g of x, right? 3g of negative 1 of x minus g negative 1 of x times x equals to 3, because we moved the 3 to the other side. Factor out g, the inverse of g of x, 3 minus x equals 3. And our final step is this right? Yeah, it's right. Just making sure. G of inverse of x equals 3 over 3 minus x. And we are done.